Hello everyone. We are team data miners and we have decided to do some analysis on Yelp datasets. So this is the agenda. So we'll be introducing you to the problem statement and how we pre-process the datasets and what algorithms have been used and all. So yeah. So why did we choose Yelp? Yelp being a rich dataset, it has all kinds of data regarding different businesses. Like for example, it has data regarding restaurants, it has data regarding medical centers, and so on. So being a big data set, we can easily analyze different trends on it. And second thing is that there are some common features that which affect every business. So considering those features, we have tried to bring up some prediction algorithms on that. And yeah, so people generally tend to have some assumptions regarding the features which affect the business. So we also had some assumptions before jumping into conclusions, but we had done predictions and found out that which feature really affects the business. Okay, so the first thing which we have done is we tried to predict the star rating of restaurants using the data we had. Like we had the like Yelp datasets were actually divided into five. So we picked out one dataset which contained about the information about the business, like what factors they are, like if there is a availability of parking lot in the restaurant or not, or whether we have say Wi-Fi, or we have waiter, how is the waiter service over there and all. And so we try to predict the star rating of each restaurant, which can also be inferred as the success. And the second thing which we have done is that which feature affects a lot uh, to the like which feature affects the most uh, in the in the star ratings.
The datasets were gathered from the Yelp.com site. It was through dataset challenge that was given by Yelp. So there were five datasets available. First was business, another were check-in, review, tip, and user. We selected business dataset from the available datasets. It has around 61,000 records in its JSON file. It was in the JSON format, and we used Python pandas for reading and processing data through the JSON file. And since we were using pandas, it was easier to use CSV files instead of JSON. So we converted JSON files into CSV files using Python library. And the main problem with the dataset was the with the column, since there were multiple columns inside the single column, and when we converted it to CSV file, there were some duplicate rows and empty rows, so we had to take care of that thing. This is the architecture for our project. So for dataset was in the JSON format, we converted into CSV file. So then we have cleaned the data. For that we did like first was updating the empty fields to appropriate values with the zeros and some with the mean values. Another thing was removing redundant rows from the table. Then we have used uh, uh, regression algorithm for the regression for performing regression on the data. So we have used four algorithms: decision tree regression, linear regression, ridge regression, and Bayesian ridge regression. The attributes field in the data was mapped to individual column in the CSV. So there were some separate columns for each individual field. So those fields were replaced with the mean values for the pre-processing, and we visualize the data using IPython library.
So for the processing part, we converted JSON to the CSV file because we plan to use pandas data frames, since for data exploration and data analysis, this is the uh, package which is widely used and it's convenient to use. So also, we also filtered the data according to business, that is restaurants, for the analysis and uh, predictive models. And one of the problem for the scikit uh, is like we need data in the format of float values rather than string values. So we usually do is like map columns to float values, and then consider like 0 is this value and 1 is this value, so that when the scikit-learn returns like 0, so we get to know like the first value we assign is the result. So there were also some uh, null values, so we replace those values with zeros, sometimes with mean values. And uh, because at some places mean makes sense, and at some point zero makes sense, so we uh, took care of that. One of the algorithms we are using is decision tree regression. In decision tree, we uh, with decision and leaf nodes is built when we use this algorithm. Decision tree is the very fast algorithm, so we choose that algorithm, and each decision node splits up into two or more branches which represent other features. um, so it is easy to understand. And in the scikit-learn there are few steps to build a model and then predict it and then evaluate that model. So there is method called fit to fit the model, and then in the fit model we pass the uh, x train and then y train, and then for the prediction we pass x test, and in for the evaluation we pass like predicted values and true values of response.
The second regression algorithm which we used was the linear regression, where so linear regression is basically used to predict some variable y on the basis of another independent variable x. So there can be two types of regressions. One is linear regressions. One is the simple linear regression. The other is the multiple linear regression. So why did we choose this algorithm? The first thing is that it is the best method to estimate parameters, and in case if we don't know what they are. And the second thing is that it is most widely used and it is very powerful, and it is also implemented without any additional efforts. And we have also implemented a ridge regression algorithm. So it is also known as Tikhonov regularization, and this is used to regularize the regression problems where the independent variable where there are a number of independent variables which are not unique across the model. And the reason we used this model was to avoid overfitting the data, because this is done by using a penalty item.
Regression is a type of Bayesian regression which also regularizes ill-posed sets of data by including some parameters in the estimation procedures. So why this algorithm is used is it handles and adapts the data in a flexible manner, and it also estimates procedure that can be enhanced by introducing a new regularization parameter. Technologies. We use PyCharm as an IDE for development. Python was the core language we used. Sklearn is the is the library provided by Python, which is used for regression algorithms. NumPy was used for statistical analysis. Then we used Pandas for data exploration and analysis. For visualization, we use Matplotlib and PyLab, which are also part of Python libraries.
Here is the comparison of various algorithms we have used. So, and the feature column represents various features we have used. So the best accuracy we got for decision tree with all the features like happy hour, alcohol, waiter service, parking, Wi-Fi, price range. Uh, so you can see all the comparison analytics here. And from all the analysis and prediction we came to know like uh, uh, there is very low correlation between the response score rating and the various features like alcohol and wi-fi, parking. So it is because people have different taste and like different things at different times. So the base score we could get is like 0.04, which is pretty low. because of these reasons I have explained. Here are the references.